Hi guys, today we're going to talk about video lesson 1.5, adding and subtracting polynomials. I'm not going to read you all these definitions, but I do need you to know them. So at some point when we're done with this video, you should read through them. Especially these here. I mean, they're all important, but on your test you'll have to know the difference between these. We really only have a special name for one term, which is a monomial, two terms, which is a binomial, and three terms, which is a trinomial. If you have an expression made up of more than three terms, 4 terms, 5 terms, 6 terms, etc., you're just going to call that a polynomial. And the other important thing, and this is the way I want you to get used to writing all of your answers, is in what we call standard form. It's when the polynomial is written with the term containing the highest degree, which is the same as the highest exponent, first, followed by the other terms in order of decreasing exponents. For example, this right here, that's in standard form. The highest exponent is 2, then it goes down to an exponent of 1, and then there's no exponent at all. Where this one is not in standard form, because you'll notice the 5, the term with the 5 as an exponent comes after the term with the 3. So you'd have to switch those around to be able to say that this polynomial is in standard form. So make sure at some point tonight, when we're done with the video, you read through these definitions and make flashcards, whatever you have to do to memorize those. These are all important terms that you'll see on your Regents exam. Now, before we start talking about adding and subtracting polynomials, I want to remind you of a certain way you can write numbers called expanded form. If you look at this number 8,943, you'll see that it has 8 1,000s, it has 9 100s, it has 4 10s, and it has 3 1s. Now 1,000, the power of 10 that's equal to 1,000 is 10 to the third, so we could also write this as 8 times 10 to the third plus 9 times 10 squared, because those two are equivalent, plus 4 times 10 to the first, plus 3 times 1. Now to find the sum or difference, we combine the parts that are alike. So for example, 417 plus 231 would be 4 hundreds, 1 10 and 7 ones, added to 2 hundreds, 3 10s, and 1 1. So 4 hundreds and 2 hundreds gives you 6 hundreds, 1 10 and 3 10s gives you 4 10s, and 7 ones and 1 1 gives you 8 ones. So the sum is 648. And the reason I point that out is because you're going to do something very similar when you're adding and subtracting polynomials. We call it combining like terms. You combine the parts that are alike. So let's take a look at letter A. We'll start with sums. And we're going to leave all answers in simplest polynomial form and identify the degree. Okay? We're going to leave these in standard form as well, which means from the highest exponent to the lowest exponent. If you take a look at letter A, you have an exponent of 3, another exponent of 2, an exponent of 4, an exponent of 5, here's an exponent of 1, here's another exponent of 4. Now standard form again starts with the highest exponent. There's only one term with an exponent of 5. There's no other terms with an exponent of 5 to combine that with. So we're going to put that term first. Negative 9x to the 5th power. Now we'll go down to the 4th power. There's actually 2 terms. You got negative 8x to the fourth and negative 7x to the fourth. You add the coefficients and you keep the variable and the exponent the same. Negative 8 minus 7 gives us negative 15x to the fourth. We only have one term to the third power, and it's negative 2x to the third. And we have only one term to the second power. It's positive 6x squared. And then we only have one term to the first power. It's positive 4x. Now, since there are no other like terms, and since all the exponents are in order from greatest to lowest, then you're done. It's written in standard form and there's no like terms to combine. Now, if you look at letter B, again, we're going to want to start with the highest exponent, which is this, x squared. And we're going to combine those. Negative 2x squared plus 3x squared, well, that's the same as 3x squared minus 2x squared, which is 1x squared. And then you have 8 xyz's. You're adding those to 4 more xyz's. So you've got 12 xyz's. These two terms, this binomial, because there's two terms, they're not like terms. So that means you're done. Looking at example C, you see there's some parentheses in there. You can't combine like terms until you get rid of those parentheses. So we're going to have to use one of our properties that we learned in lesson 1.3, the distributive property, and that'll help us get rid of the parentheses. So we're going to multiply negative 3 times x, which gives us negative 3x, and then negative 3 times negative 5, which gives us positive 15. Be careful of your signs. A negative times a negative is a positive. And now we're going to distribute again. 2 times x is positive 2x, and 2 times 6 is positive 12. Now take a look at those four terms. Remember, the most specific name for a polynomial with four terms is polynomial. We don't have a special name for that. However, I think we have some like terms to combine. We can combine this negative 3x with this positive 2x, which gives us negative 1x. We can also combine this constant, 15, with this constant, 12. 15 plus 12 is 27. So actually, that four-term polynomial was really a binomial in disguise, because once we combined like terms, there were only two terms left. Now, it looks like the exponents here are really all the same, so the order isn't really going to matter. So I'm going to start with this 2ab, and I see there's another plus 18ab. I combine those, I get 20 ab's. I've got 3 AC's. I'm taking away 4 AC's. That gives me negative 1 AC. And I have a constant at the end with no other constants to combine it with, so you end up with a trinomial. 20AB is the first term, negative 1 AC is the second term, and negative 7 is the third term. Now I'm going to show you the vertical method of adding polynomials. I don't like the vertical method myself, but I'll show you both. I'm hoping that you'll get into the habit of just using the horizontal method because I think it's easier, whether you're adding or subtracting. But using the vertical method for addition simply means take the first polynomial, 4x squared, plus 1x, plus 7, and to that you're going to add the second polynomial, 2x squared plus 3x plus 1. 4x squared plus 2x squared gives you 6x squared. 1x plus 3x gives you positive 4x, and 7 plus 1 gives you 8. You've got a trinomial. None of those terms are like terms, so you're done. And it's in standard form because it goes from the highest exponent of 2 down to no exponent at all. Now when you look between your two polynomials and you see a plus sign, you don't have to worry about those parentheses. You can just drop them. You got 4x squared plus 1x plus 7. You are adding a positive 2x squared, a positive 3x, and a positive 1. Now combine like terms. You can underline them, the x squareds. You got 6x squareds. Maybe you'll do 2 lines under the next set of like terms. 1x plus 3x is positive 4x. And maybe circles around the constants, because those are grouped together. 7 plus 1 is 8. So whether you do it horizontally or vertically, you get the same answer. Okay, example 6 is one more addition problem. You'll notice that in the first set of parentheses you've got 3 terms. 1, 2, 3. And in the second parenthesis you only have 2 terms. Don't get worried about that. That's okay. You're still just going to combine your like terms. You can just drop the parentheses. You have a 5 minus a 1t minus a 1t squared. You're adding a 9t and a t squared. You'll notice you have 2 terms that have a t squared in it, negative 1t squared and positive 1t squared. Well, we know that negative 1 plus positive 1 is 0. So these terms cancel out. You no longer have t squareds. You also have a negative 1t and a positive 9t. Those can be combined. 9t take away 1t leaves you with 8t. And now you have a positive 5 that you're just going to hang off the end. You're left with a 2-term polynomial, so it's a binomial. Now subtracting. There's a certain thing you have to remember when you're subtracting. It's very important. Example 7 I'm starting with because kids typically make a mistake when they're given a subtraction problem that's worded this way. When it says subtract this polynomial from this polynomial, a lot of students will think that that's just take this and take the word from out and put a minus in between. Well, the order's wrong if you do that. If I subtract 5 from 10, well, when you write that down, that doesn't mean 5 minus 10, does it? If you subtract 5 from 10, that's 10 minus 5. So when your subtraction problem is worded this way, you need to remember that you're actually taking 3x to the third minus 1x squared plus 8. And from that, you're subtracting 1x to the third plus 5x squared plus 4x minus 7. Now here's the trick with subtraction. A lot of students will say, well, that's easy. 3x to the third minus 1x to the third is 2x to the third. And then they'll say, okay, negative 1x squared plus 5x squared is 4x squared. You got to take into consideration that this subtraction symbol here needs to be applied to all the terms here. It's kind of like distributing through a negative 1. So we're doing 3x to the third minus 1x to the third. We're doing negative 1x squared minus 5x squared, which is minus 6x squared. We're doing 0 because there is no x term in the top. So 0 minus 4x would give you negative 4x. And then your constant, you're doing 8 minus negative 7. Not 8 minus 7. You got 8 in the top and you're subtracting a negative 7. Well, 8 minus negative 7 is the same as 8 plus 7. So you end up with plus 15. You might find the vertical method easier when you're adding, but trust me when I tell you, you're going to want to use the horizontal method when you're subtracting. So here's what I tell kids to do when you're subtracting. First, write it out. 3x to the third minus 1x squared plus 8. From that, we are subtracting 1x to the third plus 5x squared plus 4x minus 7. Now, if you had anything to distribute through the first set of parentheses, it would just be a positive 1. And multiplying terms by positive 1 doesn't change anything. So when you're adding or subtracting polynomials horizontally, like we're doing here, you get to just drop the parentheses in the first set. But here, what you're really doing here is distributing a negative 1 through these parentheses, which makes this first term a negative x to the third. It makes this second term a negative 5x squared. It makes this third term a negative 4x. And it makes this fourth term a positive 7, because a negative times a negative is a positive. So when you're subtracting polynomials, before you combine like terms, make sure you change all the signs in the second set of parentheses to their opposite. And then combine like terms. 3x to the third minus 1x to the third gives you 2x to the third. Negative 1x squared minus 5x squared gives you negative 6x squared. You have nothing to combine this negative 4x with, so we'll just say it's negative 4x. And positive 8 plus 7 is positive 15. We got the same thing over here as we got over here. So let's do a few more examples of subtracting, a couple more, and then you'll be good to go. So example 8. We've got 3x to the third plus 8x. We are subtracting a 2 times x to the third plus 12. I like when they don't just put a minus in between the two parentheses. When they put a negative 2 there, it's more obvious that you need to distribute through the second set. So we can drop the parentheses here. But when we distribute, negative 2 times x to the third is negative 2x to the third. Negative 2 times 12 is negative 24. Notice the signs of those terms in the second set change to their opposite. Combining like terms, 3x to the third minus 2x to the third gives you 1x to the third. You have a positive 8x with nothing to combine that with. You have a constant of negative 24. That's your answer. All right, one more. Here we're not only adding, but we're subtracting. So let's write this down. This first one, nothing to distribute except a 1 in the front. Distributing by 1 won't change anything, so we're just going to drop those parentheses and write 3p plus 1. Here we have a 6 to distribute through. 6 times p is positive 6p, and 6 times negative 8 is negative 48. And here, remember, it's really like having a negative 1 times p plus 2. You got to distribute that negative 1 through the parentheses, which gives you negative 1p minus 2. Now you're ready to combine your like terms. 3p plus 6p is 9p. Take away 1p is 8p's. You've got a positive 1 minus 48, which is negative 47. Take away another 2, you're at negative 49. So this is the polynomial that is the difference between, well, this sum and this difference. This polynomial is a binomial because it has two terms. Okay, so we're going to practice this more next time I see you in class. If you could do me a favor and take a look at the vocabulary on the front page, read through it. My rule of thumb is if you really want to remember vocabulary, if you read through that 3 times, maybe 4 times, you'll remember them. Okay, so I will see you in class, and you guys have a great night.